have a vector question, and we're told that this is a parallelogram and this shape here is also a parallelogram. So the first thing I'm going to do is put on any other vectors which I can. Now we're told that to go from P to U, that is the vector A. So any other vector which is the same length and parallel to that will also be vector A. And I can see that this one here, ST, is parallel and it's the same length because it's a parallelogram. So that is also the vector A. Now vector B is this one from P to S. Again, we're told that this is a parallelogram, so QR will be parallel to PS and the same length, so this is also vector B. And for the same reason, over here, we also have vector B. Vector C goes from P to Q. Again, this is a parallelogram, so S to R will be the same vector because it's parallel and the same length, so there we have vector C. First thing it asks us to find is the vector TQ. So here's T, and here is Q, and it doesn't really matter which way I go. I'm going to go from T, let's go from T, so I'm going to go from T to U, and then I'm going to go from U to P, so that means I'm going to add the vector UP, and then I'm going to add the vector PQ, so I'm going to go that long way round. Now, if I fill in the A, B's and C's, TU is going in the opposite direction to B, so it's minus the vector B. UP is in the opposite direction to A, so it's minus A, and PQ is this vector, which is in the correct direction, so it's C. Now, just to tidy that up, I'm going to write it as the C first, minus A, minus B. Just makes it a little bit neater. So that is the vector TQ. Right, we're now asked to find the vector Px, where x is the midpoint of TQ. So the first thing I'm going to do is I'm going to put the midpoint of TQ. Let's just draw on that vector, the vector TQ. Let's do it in green. So the vector TQ is this one here. Okay, and if I just write on that one, so the vector TQ is this one, and we already know something. We already know the vector TQ. It's over here. And we're told that x is the midpoint of TQ. So in fact, let's just rub that out. So the midpoint of TQ is here in the middle, okay, and we're going to call that point x. So the distance from here to here, from Q to x, is the same as the distance from x to t. So we're trying to find the vector that takes us from P to x. And I'm going P to Q, and I'm going to use TQ to help me. So from P to Q, what I'm going to do is I'm going to go from P, let's say from P to T, and then from T to Q. So I'm going to go from P to U, and then from U to T. So I'm going to go from P to U, and then I'm going to go from U to T, and then I'm going to go from T to X. And the reason I'm going to do that rather than going the other way around is that I've already got TQ. It's easier to go, if I've got TQ, it's easier to go TX than it is to go QX. Okay, so the vector PU, well, that's A. The vector UT, well, that's B. Now this TX is actually just half of TQ. So the vector that goes from T to X is half the vector TQ. So it's going to be A plus B plus a half of this vector that we found earlier, which is C minus A minus B. Now it's a bit of a mess, so I'm going to tidy that all up. So I've got A plus B. Now removing the bracket, I've got half C minus half A minus half B. So let's collect the A's, B's and C's. A minus half A, well that's half A. B minus half B, well that's half B. And then half C. So the final answer there is that the vector PQ is actually half A plus half B plus half C.